Good afternoon, everybody. Welcome back from lunch. Hopefully you all survived that line that was out there and actually managed to get food, unlike some of us. Yes, the line champions over here. Got there early. So I'm very excited. My name is David Crawford. I'm the product owner for the Utility Network. Very, very happy to be here with you today at the Dev Summit, walking through a new session that I've sort of built up. We used to do a couple different sessions, an intro, an advanced, and a network diagram section. So this is the first year we're going to try to take a stab at putting them all sort of together. So let's dive into it. So as a reminder to everybody, at the end of the session, if you could leave your feedback. As I say, it is a new session we're trying out. I'm very curious to hear what people think about it, good, bad, ugly. If it's bad, you can blame Melissa. If it was good, you can blame me. It's all good. So thank you very much, and then off we go. So what we're going to cover today is a little bit of introduction and overview. So I'm going to cover some of those introductory topics. What is the utility network? What are the components that make it up? And then we're going to dive right into sort of how do we actually use it. So we're going to dive into some more advanced topics of sort of what problems can it solve, and really all that means is how can I actually use it, and what real world examples can we come up with that would make sense depending on the industry that you're in. Then I'll talk briefly about sort of where can we use it. It's a very odd way to describe GIS, but the reality is we're getting into a more disconnected, a more mobile world. There's mobile workforces now, there's disconnected workforces, so there is a different way to consider some of these things. And so we'll just discuss sort of where the different areas are and how you can use this thing. And then we're going to leave you with where do we go from here, sort of what does the future look, what's new and coming in the next release, and a bit of longer term, and I'll leave you with a bunch of resources and things you can access to learn more about it. And lastly, we'll go over the questions that you guys have for us. We are live stream, so anyone on the Pigeonhole who's there can type in questions. Melissa will get them and interrupt me along the way. I run a little bit of an informal session, so if you have questions along the way, you're welcome to throw your hand up, yell them at me. I'll repeat them for everybody online and everybody in the room so we can all hear it, and I will try to answer them as we go. If it gets too long-winded and we're going to run out of time, I will stop us and then delay those questions to the end, or if the question is too complex, I will defer it to someone else on my team who I can blame for a bad answer, and we'll just sort of roll our way through it. So off we go. Introduction and overview to begin with. So what is the utility network for anyone who's unfamiliar with it at this point? It's really what we introduced as our next generation network model for utilities and for the utility industry. There are certainly non-utility industries and workflows that I've seen over the years that people use with the old geometric network that you could certainly still use with the utility network. There's no requirement that it be a utility. It's just obviously the target market, the target demographic that we're looking at when we release these networks. It is a services-based architecture. It was the first data set that we released that was services-based. It supports versioning, so this is the branch versioning model that we support through feature services, providing long transactions. We also support a short transaction model against default directly. We also have single user versions in file geodatabases and mobile geodatabases that you can get access to. We support offline or disconnected workflows. So as I said, sort of where can we use it? All these different modes of operation coming online, and offline and disconnected is certainly one that we've focused on for the last several years. It maintains a network topology. All this really means is we build a graph internally of how each of the features or objects in a network connect to each other. It's not to say how they specifically trace or traverse with each other, it's just how they connect together. And we'll get into that in a little more detail as we get into some of the more advanced pieces. It enables tracing, the ability to find out how things in your network are actually connected, directionality of flow in your network, as well as a basic connected trace. And we also support network diagramming. So for anyone in the geometric network world, this is what we called ArcGIS schematics as the extension. It's a more modern version of schematics that's directly integrated with the network. So there's no side builders of having to sort of bolt it on the side of your geometric network. It actually just comes right alongside with your assets and your utility network data itself. So what does the architecture of this thing look like? We always say a services-based architecture. This is a diagram that's flown around through different slides over the years and different presentations. All it really highlights is top to bottom, we have end user applications, whether it be ArcGIS Pro, our SDK, whether it be native apps coming at us. These all go through some form of a translation layer. In this case, we've described it as the geodatabase. but really, or feature service workspace or SD workspace, really it's just any layer, whether it's the core that native apps is talking to in the kernel or Pro itself, some layer that is going to take whatever operations you're doing, convert those into an HTTPS request through JSON across what we call the JSON barrier there that gets you down into our REST APIs, which then communicate to all these servers, where all the operational work is actually happening on the back end in that gray box at the bottom on ArcGIS Enterprise. I'll give you all a moment to take a photo of that. I saw a bunch of cameras come out. And so that is the traditional architecture we've now been talking about for quite a few years. But it's always good to remind people what services-based architecture actually means. And then the broader part of it is, what does it actually support? So why did we do services-based architecture? Well, by putting everything in the middle in this service tier, serving out REST APIs, it means the desktop applications can talk to it. It means your mobile devices can talk to it. It means the web can talk to it. And all these different clients can speak to the same unified database via these REST APIs. It gives everybody the same view of the network, same access to the data, sort of wherever you are in your ecosystem. Within that, there's different SDKs and APIs that give you access as an end user. So some of those don't expose all the functionality as all the other ones. And we'll get into that a little bit later on about sort of which application and which access path makes sense. But that's really why we went services-based. It was the only way to light up the entire platform and make it fully accessible without burying sort of behind that enterprise geodatabase, where then you have to write a whole bunch of translation layers and everything else to make it work. So what are the key components that make up the utility network? Again, sort of bringing us back just sort of the foundational principles of the utility network. Obviously, the utility network can be used to model any domain, as I sort of highlighted at the beginning of this. These are 4 of the common ones we often discuss: water, gas, electric, telco. But really, there's any number. Over the years, I've seen a logging company that monitored log traversal down a river using a network. So it really is anything where you're transmitting a commodity from one location to another. The network gives you that ability to connect those assets together, create a graph, and then trace along that graph. So the highest level item in a utility network is what we call our domain network. Each domain network provides you a schema to use to populate with your data. Every schema includes a device, junction, assembly, and line feature class, and it contains 2 non-spatial tables: the junction object class or table and the edge object table. This is for some more advanced modeling that people are doing, where they're actually modeling the units associated with a device, like a transformer unit, or something that sort of is where the actual connectivity is happening, or the more detailed information about an asset is being stored as something non-spatial. But the actual thing on the map is a spatial feature. That might be a switch or a switch bank spatially, but might be 3 switches in your actual graph. To save yourself the spatial clutter, you can model that as a spatial feature containing 3 non-spatial objects. That's sort of why we give you those non-spatial tables. You're under no obligation to use them. If your modeling doesn't make sense, you are not required to use the non-spatial. It is there if you have a use case for it. I can't imagine many water utilities that want non-spatial representation of valves, but who knows? You could always do customers, though, as a non-spatial component connected to the network. We also store the description of how the domain itself is modeled. Is it partitioned or mesh? If you looked at those 2 words and thought, I have absolutely no idea what those mean, you are likely not working for a utility who has any concern about the more advanced capabilities of the network. And you're probably just going to use a partition network, because that's the most basic version of it. You can also set whether or not the domain is driven by sources or sinks. You can imagine sources being things like electrical grids, where circuit breakers sort of feed the electricity out, and sinks more things like gravity-fed networks, where the sink actually draws everything into it, the more river-style networks. Domains, or domain networks, contain tiers. Tiers define the configuration of how the assets in your network relate to each other, trace with each other, and are supported in each of the tiers of your network. So each tier can define a valid set of asset groups and asset types that make sense. It can say that these kind of devices only exist in my distribution tier. These kind of devices can only exist in my transmission tier. And we will generate errors if features are placed in a tier where they are not valid. We also, on each tier, include a subnetwork configuration, a trace configuration, which allows you to set up how the traversability of all those assets actually works, and how is it that your network is actually subdivided. And there's some examples there of of what people commonly use as tiers, distribution, transmission, things like that. Then we dive into asset groups. So asset groups are subtypes in the geodatabase verbiage or vernacular that we use. It's literally the same thing, it's just called an asset group. Things you can imagine for asset groups in devices, switches, transformers, valves, pumps, sort of the big category of item. If you have a three-way switch or a T switch or a V-blade switch, that's not really the subtype. The switch is the subtype. It's all the other configuration and details about it are a different thing, and we'll get into that next as to what they are. So we support our asset groups on devices, junctions, assemblies, lines, as well as the edge object and junction object table. They all require asset groups in order to be configurable and to be usable. And the next tier down is these things we call asset types. You can think of it as a subtype within a subtype. It really is just a further discriminator that provides that more detailed description of what the device is, what the junction is, what the line is, what the edge object or junction object actually is. So if your switch is your asset group, the V-blade, T-blade would be the asset type. Again, giving you that further discrimination of what it is that you're actually representing in your network. The next core component of the utility network is our network rules. So the utility network, unlike some of our previous network models like the geometric network, have what we call restrictive rules. That means if you do not give us a rule that tells us two things can connect, something can be contained inside of something else, something can be structurally attached to something else, then the assumption is, and the system will enforce, that they are not allowed to connect, be contained within each other, or structurally attached to each other. They are restrictive rules in that if you don't give us a rule, we will generate an error whenever those conditions occur. Usually that just means when you find those errors, you have to add a rule for what we call the one-off occurrence. People will model their whole thing out, think they have the greatest rule set that's a perfect representation, and then load data in and realize they missed some things. There's actually weird connectivity going on in their network in some way. You can either add a rule or you can fix the network. Up to you. But rules are very important as part of the utility network. We support all these different kinds. And the last sort of key component of all these things we support is associations. These allow us to model the explicit connectivity of assets. So former models, they only worked off of geographic location, actual geometry. A point had to actually physically snap to the endpoint of a line for them to be connected. And they had to be coincident on the X, Y, and Z axis. Whereas using associations, you can just tell us, hey, this line connects at its endpoint to this junction. They can be a little bit offset, and you can set that up. This junction can connect to this junction. The common example we have in electric is typically jumpers. If you connect a connection point or a tap-off point to a transformer, you're not typically loading the jumper cable into your asset system, but those things do actually connect. You can optionally use non-spatial edges to model the same thing. The difference between those is that associations do not support attribution, and we have an entire UX and UI built around working with associations, and non-spatial edges can be a little bit more cumbersome to work with because it's just rows and tables. But if configured correctly with their associations at their endpoints, you can model the same sort of thing with attribution. And as I said, we do support all these different types of associations. We have connectivity associations between junctions and edges. You can set things at their endpoints or at midspan. We also have containment and structural attachment associations. And I'm going to take a momentary breath for a second. And now we're going to dive into a demo. So This is what I call the introductory demo of this thing. So in this example, I have an electric network loaded up here. Couple things to highlight. So the actual network itself is a layer in my map. Within ArcGIS Enterprise portal server, it is an item. It is an actual recognized type in my server. So there is configuration that you can do on this ArcGIS Server Manager on the portal to actually configure these services. I will let you in on a secret. This is not a service-based utility network because I don't hate myself when I do demos live. And so we work locally here on a file in mobile GDB. All of the properties and things I'm going to show you are the same, but the actual access path is a little bit different, and I can't show you necessarily the portal side configuration, but it's all about the same. In order to work with this file or mobile GDB in Pro here, I have to have a standard or advanced license of ArcGIS Pro. In order to work with the services-based ones, we are especially as of 3.7, you're using named user licenses, which means you need to be a creator with the advanced editing user type extension assigned or higher, professional plus, to be able to work with our utility network tools and utility network data. So within the utility network layer itself, we can actually go down and look at the network properties. So just to prove, I suppose, I wasn't lying, we give you a summary at the top about the lineage of the network itself. So we actually tell you where it was created, where it was upgraded, what versions of the software it was used to upgrade. This often is very helpful for a lineage if you're ever curious, like, why is my network not working the way I thought it was going to work? I thought it would be a version 7. It's actually a version 5. What happened? We tell you the version of the network here. And obviously, if you don't see anything that's been upgraded, it would give you a clue that you created at an older release and it hasn't been upgraded since then. And you can see where it was created. Down here, we give you a little summary of the network topology itself. So as I sort of hinted at, if you create data which is bad, when we validate or enable the network topology, we generate errors. In this table, we show you a quick summary of how many errors you have in your network. I have top-notch editors, so I only have 2 errors in my entire network here. I still have someone to go yell at because it's supposed to be a clean network, but you can see we are pretty clean here. A lot of networks aren't clean, but you can get a pretty good sense here at the top level as to how clean or dirty your network is and what shape it's in. And then we give you some good metrics here on enabling topology, when's the last time it was enabled, the full enable, and your build statistics. And then we give you all the information you could possibly need about the network itself. In fact, I'm going to say we probably give you way too much information in here in a non-readable way, but domain networks are first. So structure network, everybody gets. The structure network, you don't have to use it, but it comes for free with the network itself. So it's like getting 2 for 1 when you add your own domain network to it. You do have to configure it, though. There's no asset groups or asset types by default, so you do have to add those in if you want to leverage structure. And then, in this case, I've added an electric domain network to it. As I see up here in the little description of my domain network, I can see the tier is partitioned. All partition means is that each segment of my network is completely isolated from the downstream segment. I can't have high voltage connecting to medium voltage without some open switch or something that is transitioning it to the next tier down. If I try, I'm going to end up potentially blowing things up in my electric network, which is not going to be a great feeling for anybody. A mesh network in like water, it actually allows subnetworks and definitions and tiers to feed into each other. So you have like a master tier and then one within that and then one within that, giving you these zones where they can all sort of feed into each other. They're mostly only common in what we call mesh networks, which are like pressurized networks where it's literally just a gigantic loop. If you actually step out at a big enough level, it becomes literally a gigantic loop. Within our domain network, we have our tiers. So in this case, it's electric. So I have things like electric generation. I have electric transmission. As I move to the right, I can see all of the valid devices that can participate. in this tier. So I can see as I go left to right, I can see the lines that are allowed to participate. I can see the lines that are aggregated into my subnetwork line. I can see my junctions that are allowed. And at the very end of it, I can actually see a trace configuration. That one doesn't have a GOM, but this one does. So this definition, this trace configuration, is going to say that for any features within that tier of my network, the subnetwork is defined using this trace. So as long as I have open points and I have open things related to each other, the traces will stop, my subnetworks will be consistent, and I will be able to run update on these things. So now, getting away from tiers for a second, you can see all of the classes, the device, junction, line, assembly, and the two non-spatial tables. If I open them up, I can see the asset groups I have assigned. I can see the asset types I have assigned. I can see what role this thing plays. Is it a container? Is it a structure? You don't have to tell me something can be content. The sheer presence of a containment rule with it as content makes it content. You do have to tell me if something supports being a container. It's ease of use. And then within that, there's other pieces that come out of that. What is the view scale if you open a containment mode? How does that work with diagramming and other pieces? And so then we have all of our other types. As I say, non-spatial, same thing, asset groups and asset types, same configuration available. You can see all of the different rules that you have in your network. If I start to expand these, you can see all the rules. If you are familiar at all with the geometric network, these rule types, before you get to containment, are actually the same as the old connectivity rules in the geometric network. These ones are just actually enforced, unlike the geometric network. I should have brought more water. And then below that, we have network attributes. I didn't highlight network attributes in the intro section. They're a bit more of an advanced topic, but they do drive a lot of the analytics and the tracing that we get into. So these are special attributes that you tell the system, hey, these attributes mean something. If someone edits one of these attributes, I need a dirty area to be created because I need the network topology to reflect that new attribution. I need it to impact my tracing operations. If something is not a network attribute, you can get it returned through tracing, but you can't actually use it as a control of tracing. So in here, you can see the names of all the attributes. You can see what they're assigned to in each of the feature classes down here. And we sort of just go through the rest of the network. The other interesting part of this is these categories. Some of these categories are system maintained and created. Things like, I actually don't know off the top of my head, but I'm going to guess things like subnetwork controller, subnetwork tap. These are a category you have to assign to certain asset groups or asset types to be able to create them as controllers within the subnetwork itself. So that's sort of the 10,000 step foot introduction of the network. And I'm going to say that now it gets a little more fun for me. So if that was sort of the introduction of it all, and now we're going to jump into a bit more of the advanced piece of this. So as I say, it's kind of 3 presentations I've slammed into one. So that was the introduction piece. Now we're going to jump to the advanced piece, which is going to include in it some tracing, diagramming. I'll show a bit of editing, and we'll just sort of walk through how it all works. So as I say, the way I phrase it is what problems can be solved, because as I go through some of these demos, I'm going to sort of give you examples of what it is you're actually using these tooling for and what you're doing in the application. But as I say, from the simple to complex. So you can answer the question of where are my GIS assets located? You actually don't need the network for that. That just is the points and lines and polygons that are drawn on the map. You do need the network to answer a more complex question like how many poles are there in my entire network? How many poles does a specific subnetwork utilize? Do I have shared use poles? Things like that. These are questions that under the old geometric network and some of our old network models were just really hard to answer. You could answer them, but it took a couple steps and it wasn't straightforward. Whereas with the utility network, because that structure is actually built directly into the network itself, you can answer it as part of the analytic operation itself. And then you can also answer things like how many customers are affected if a transformer goes out of service. And then sort of just some examples that we'll sort of show some of these as we go through it, of tracing that you can get done. So you can do nearest upstream protective device. Thank you. Excuse me. You can do valve isolation tracing. So some of these things used to be multiple step operations you have to use, and a lot of them now we provide out of the box as ways that you can access and leverage the information that's already in your network in a way that makes sense to people. We also support phase-based tracing and tracing using digitized direction, which is a nice enhancement we added with the version 7 networks a release and a half ago. And then some other key examples we're going to walk through is network diagrams. Network diagrams don't always get their due in some of these sessions, which is one of the reasons I wanted to sort of combine it into this session, because there is a lot of power in network diagramming. I have yet to see a utility who does not have schematics somewhere in their network. I've yet to meet an electrical engineer who thought, I love GIS maps and I hate schematics. I've heard quite the opposite from almost every one of them. And so we've integrated these diagrams directly into core, but they don't always get highlighted. So I'm going to take this session and make sure we highlight it along the way to just show some cool examples of what you can do. They're all very customizable and very, very unique in the way that we manage them. And so I'm just going to dive right into the demo of our advanced concepts. Before I do that, as I take a drink, does anyone have any questions up to that point? I did zip through quite a bit of content along the way there. Go for it.
Is this only limited to real utilities like water, power, and so on? Or can it be also used for transportation networks?
Okay. So the question was, is this network limited to only actual utility networks, or could it be used for anything else, transportation networks, for example? So it is not limited only to utilities. There is no piece of this system where we are like, if you are not a utility, we're going to ban you in some way from using it. There's also no piece of the configuration where we say things like, are you electric? And if you pick that option, you get a bunch of stuff. Right? There are data models, and there are solutions, and there are business partner solutions all built on top of the network. But the network is, at its core, a framework for other people to build solutions and end user tooling on top of. We certainly deliver a certain amount of end user tooling through Pro and through some of our SDKs, and we try to make things as easy as possible to consume. And we often bend our biases towards the utility industries. So some things like subnetworks. It's a very common term in electric. It's not so common in water and gas, where they typically think of things as like zones, but we sort of bent the terminology to electric because it was the biggest utility market we were going after, while then finessing it to fit the other markets without totally leaving them out to dry. But if you tried to make a subnetwork in transportation, it would be A, very confusing, and B, I would tell you should probably go use the transportation network or the network data set that we actually offer for transportation. But yes, if you had some other industry that you wanted to support and you could imagine you want these things connected and you want to see things traverse through it, there's nothing to stop you from doing it. You would just have to choose how to model it yourself, how to build a data model that made sense, and then how to leverage the infrastructure around it to make it work. That was a good question. Give me time to breathe. Sort of. So I'm going to jump between 3 different networks. I'll show you the 3 networks first. We're going to jump between, and then I'll start doing it. So this is a basic telecom network. It's, as you can see, a very basic one. It's got a single ring plus a few offshoots. It is built on our utility network, what's that actually called? The communications model from Esri's solutions team. It is not leveraging the telecom domain network, which people may have heard of or not heard of at this point. But we are releasing something called the telecom domain network. This particular model I'm showing does not leverage that domain network. So if anyone's looking at this and wondering what I'm showing or anything else, it's just the comms model from solutions. I have this one, which is a sample data set from the electric model provided by solutions. And then I have a water sample. So I like to highlight all these different domains because I really want to cement the point home that we are not stuck to a domain. The utility network is very domain agnostic. Whatever you bring to the table is what we will provide back, so long as you give us enough information to help you along the way. So, first I will start with my electric network. So, looking out here at 10,000 feet, I can see all these fancy lines. These lines are actually what we call our subnet lines. These are a visual representation of each of the subnetworks within my utility network. With this release, we actually did work on what we call this Find Subnetworks pane. So this pane can be used to show you all the subnetworks currently in a map. You can use it to show all the subnetworks currently in your entire network. And formerly, you could right-click on any of them and just trace the network or get a little bit of information. Now, with some of the enhancements we made here at 3.7, so I'm a risky person at this point. I'm showing 3.7 and I have 12.1 on this machine, and so, but we figure why not. So I can trace one of these subnetworks. So I can see that the subnet line actually highlights. But one of the big enhancements we actually added in here is I can right-click a subnetwork and I can just select the controllers of that subnetwork. So I no longer have to run that trace and then go and find the feature feeding that, or go to that subnetwork, drop a starting point and say, go find me the controllers. You can directly off this pane now go and find those subnetwork controllers. And what is cool is this is electric, so we can do tracing. Tracing of these subnetworks is canned based on whatever configuration the tier has. That's what this subnetwork is going to use. On the utility network ribbon, under my gallery, I can get access to all of our different trace types, though. So I can see the subnetwork trace. If I open it, and I pick my domain network, and I pick that tier. And the reason for a subnetwork trace, this is true for any directed trace, upstream, downstream, or anything in between, we make you pick the tier. That is so that we can pre-populate the tool with the configuration that you have for that subnetwork. But let's say you wanted to play a what-if scenario. What would happen if this subnetwork, what if I just removed one of these configurations? Operating status normal is equal to open or traceable. So if I get rid of one of these things and I rerun the trace, it's going to fail because I forgot to put a starting point down, I'm going to assume. Yes. So first, you have to actually launch this trace pane, and you have to add a feature as a starting point. Then you can run the subnetwork trace. So the pane works without a starting point added to it because we take the subnetwork name and we execute the trace. The trace on the GP tool requires that you've given us starting points to work with. So that was sort of the inadvertent example of why you have to pay attention to what you're doing in Pro. The starting points and the tracing configurations are available via all of our SDKs, all of our platform. Tracing is the one piece that's available everywhere that you go across the whole thing. So you can see I modified the trace configuration, I ran it, I got what may or may not be a different version of this subnetwork. I didn't fully keep track of that count, so I'm not 100% sure. But I can also change the trace, so I could say go downstream from this location. So now instead of doing a subnetwork, or maybe it goes down to an area and it sort of fans out and it might go back upstream and find a whole area that's fed by this controller, I'm saying just go downstream. I can rerun that trace now. It's going to use that starting point and just give me a downstream trace. And the coolest part of this whole thing is if I clear my selection, I have this starting point using a diagram, and this diagram was actually custom built. So with any network diagramming, we can expand them by using GP models. So for example, if I look at this switching model, you can see it's, oh, Jesus. So for anyone who doesn't know, if you use a Pro map and you're not on the pan tool, you can hold C and it becomes the pan tool. But if you're in Python or in the model builder window and you hold C, it does not become the pan tool, as I discovered repeatedly as I'm doing this demo. So within these diagram templates, just again, it's a bit of a jump all over the place and sort of a quick jump into some of these advanced concepts. But within diagramming, you can gather features up, you can assign rules to them, you can limit what's in the diagram, you can expand what's in the diagram. We actually have the ability to run traces directly through the diagram. Right here, there's the thing called this add trace rule. In add trace rule, you can actually configure a full trace, so in this case it's a subnetwork trace, that executes along the way. So now, from that same one feature, don't save that, from that same one feature, I can actually go and just generate a switching diagram for that entire subnetwork based on purely the single starting point of the subnetwork's controller. Takes a second to load up. And then this diagram, for anyone who works in electric, this would be familiar. If you don't work in electric, what it's showing you is we aggregate together every line or device that is not beneficial or helpful to a switching operation, and then we just highlight those things, the switches around this subnetwork that are used to control the flow of electricity. You have a question?
I do.
Okay.
I'm curious about the overlap between UN and knowledge graph. For a non-out-of-the-box industry, would there be scenarios where you would implement using knowledge graph instead of UN?
Okay, so I'll repeat that because I don't know if the people at the back heard. So the person is interested in the crossover between knowledge graph and the utility network. And if there is workflows where it would make more sense to use the utility network versus knowledge graph or vice versa?
Would there be scenarios where you would implement using knowledge graph instead of UN?
Oh, is there areas where you would implement using knowledge graph instead of utility network? That is actually a much longer conversation than you might imagine it is. There is overlap in that knowledge graph uses a graph, and it processes using graph databases to create connections between things. There is not overlap in that knowledge graph doesn't really provide directed tracing. It doesn't provide things like, it provides a theoretical direction, but it's like human direction as opposed to asset or commodity direction. I don't know if that fully makes sense, but hopefully the person online can either say it did or didn't make sense. But that's our switching diagram. So the other traces I wanted to show were sort of, so in our telco model, just to sort of highlight that all the same stuff works over here. So as I said, it's in the comms model, which means I have access to this Find Subnetworks pane. Over here, again, I can trace to see what each of these subnetworks looks like. And what we have in diagrams is I can actually, let me just, one moment, select the controller. That's actually more helpful than you might imagine it is. I can launch, I can create a cable diagram, which is going to go from that one junction I had selected, find the cables that are connected to it, show me all the points along the way, and then draw it out with labeling and with a description of what's going on. The cool part of diagrams that doesn't always get noticed, because we've had discussions with people where they will say, well, that looks cool. What do I do with it? Because this one's obviously temporary. You can store diagrams. They can be persisted in the network database itself. You can also edit these. So I can actually go into editing and I could say, you know what? This area here, I don't really like the way it looks, so I want to move it over here. You get the same rubber banding experience where connected things will come together and try to keep them moving. You can disconnect the rubber banding by clicking this disconnect button down here, and you can persist it. And then I could save this diagram so the next time I open it, it opens exactly like I edited it here. So I'm not forced to constantly do white space editing. I can create my substation looking exactly like what I want it to look like. I can persist it, and then I can open it later based on a good naming convention to be able to grab it. I could save it or not save it. And then one of the other cool diagrams that we have here is this one we've been asked about before. And I don't know that I've ever actually shown it, but let me just get rid of my edit so I can actually launch something here. Yeah. I broke Pro there, so we're just going to jump to my other one. Well, that's thinking about it. One of the other cool traces that we offer that used to be in the old world a really complex trace to do is a valve isolation trace. So let's say, for example, somebody in a water network has called me and said, hey, there's water spewing out of the main on my street. We have to be able to go isolate that line. So in this case, I have a junction right there, and I say I need to go and find what valves do I need to go turn to turn this thing off. In the old network, you had to sort of trace upstream, find things, turn around, and trace back downstream and do a bunch of work. In this case, I can simply say, I'm looking at my water network, in my water isolation tier, and the one thing you have to set on a valve isolation trace is a filter barrier. The reason for this is, for anyone who came to my demo theater yesterday, traversability will prevent me from tracing at all. So if I was to set a traversability barrier to say, stop when you find open switches or open valves where water is going through them, I will never find my way to a subnetwork controller to know what valves I need to turn off in order to block them, because I'm going to stop almost immediately once I hit the first valve that's open. What I need to do is have it run the whole trace, find the controllers, then turn around and rerun that trace and say, where are the valves that would prevent anything from getting to me from those controllers? So the way we do that is through what we call filter barriers. Filter are the second pass of a trace. So in here, I could say, find me all valves which are currently open and all valves which are operable. Not false, true. And the reason for that, obviously, is that if there's a valve next to me but it's paved over or it's rusted shut, I can't turn it. So it doesn't really benefit me to hear about that valve, because the guy in this field is going to go there and say, I can't turn it. So that's why we maintain operability often in water networks, so that you can do that. So you can see that result. It's these three valves. The interesting part of this one is that we've embedded directly into it some more logic to say, okay, so I've created some valves that isolate me, but who do I have to go notify? I have customers I actually have to notify. You're going to be out of water for some period of time. So I can just check this box that says include isolated features, run that same trace. It's now going to give me the valves to isolate and the entire set of features within it that are being isolated. I could then evaluate that set to find the customers, and I could then say, hey, all these customers, I got to notify them, phone them, what have you, to let them know that they're going to be out of power or out of water. And then hopefully this came back to me. We'll see. Oh, it's down here, that's why. Yes, go away. And then what I wanted to show was if one of the other cool things that has been built, and is actually out there as a sample that you can use, is a straight splice diagramming. So in telco, splice connections can be a little bit crazy to configure and see, but you can actually see on this network diagram that we can create them. And so down here, you can actually see, oops, as we cut across this connect. Now this is a straight through splice. There's no actual splicing happening in here, so it's all just straight lines through. But you can imagine that if I had moved some of these things around, the lines would change, things would go in different directions. It's quite a powerful functionality that the diagramming team has built into this and exposed. So that is your quick run through some of the advanced concepts of the utility network. And the last part of this whole thing is where can you use it? Yep, go ahead.
Quick question.
Sure.
At your demo yesterday, one of the things that you were highlighting on your trace tool was the validate consistency and whether it was able to include dirty areas or if it was stop at a dirty area.
Mm-hmm.
I had the question yesterday but forgot to ask it was, does it only skip over the error red dirty areas? If you use validate consistency, would that also do the validate utility network, where if it was a purple area that is correct but just hasn't been validated, will it validate that for you?
That's a very good question. So one of the things I highlighted yesterday in the demo theater that I gave was if you actually look at the trace tool, which I just lost somehow, but here it is. If you actually look at the trace tool, there's a little checkbox here that says validate consistency. On the GP tool, we check it by default. What it means is as we run the trace, we will, when we finish the trace, we will check were any of these features that were traced in a dirty area. Not an error dirty area, which is the red one. It's actually either the error dirty area or the edit dirty area. And then the follow-up question to that was, will we automatically validate it if we encounter these things and you've checked the box? No. We will just error at you and let you know that you've gone through an area that is inconsistent and you need to update the topology or validate the network topology before we can for sure guarantee it is clean. Good question. And so now I get into where can you use it? So it is served by ArcGIS Enterprise. This is the most cumbersome slide to put in place into a deck like this because you technically can use it from the server directly if you really love writing against REST APIs, but you're not actually using it there. You're just using it from there, but it is the underpinning of all of it. So ArcGIS Portal is where we get licenses from. It also stores item definitions for the utility network. It also stores configuration. And actually with each release and with the 12.1 release, we've added even more configuration functionality directly into Portal. So you can turn on and off specific capabilities of the service without going to Server Manager. You can actually do it all directly in Portal now, where previously you had to go to Server Manager to do it. So we're really trying to elevate that experience up into Portal. ArcGIS Server, as I say, is just the service host. It is where the services, the SOCs actually live. That is where all the operational processes exist. And it is fully extensible using the Enterprise SDK, which you can write SOIs and SOEs to extend. You can obviously consume it through desktop, through Pro, as I was doing. We have full support of file geodatabase, mobile geodatabase, single users using the minimum license of standard. We also fully support services accessed via Portal and name user licenses. We also support offline workflows. So there's a download map button in Pro. And with recent releases, if you click that button, we will actually take the whole utility network offline for you in the extent that you're looking at. Allow you to work offline before you sync back up and reconnect to the service. And as I say, it's customizable using ArcPy or one of the Pro-managed SDKs. You can use it in the web. So this all circles back to that first diagram, right? The utility network's in the center. Everything sort of connects around it. We have the ArcGIS Maps SDK for JavaScript. That's how you access things through the web. It currently has native support for editing, tracing, associations, validating. There's always more enhancements coming along the way to the JavaScript SDK. But as I sort of my note at the bottom is all of our UN APIs or all of our UN functionality is exposed via a REST API. So JavaScript, you can always write a direct HTTPS request if for some reason the native API isn't there. And then when that API is there, you delete your code and replace it with a single line and off you go. And these are just some examples of like getting the utility network, some of the things we've made much easier in the JavaScript API. Creating trace configurations. There's actually a tracer object now, so you can just call trace. You don't have to build up the whole HTTP request. We'll do it for you along the way. And then mobile, which is the ArcGIS Maps SDK for native apps. In there, we currently have support for editing, tracing, associations, validating, versioning, and disconnected workflows. So again, you can use that to take a segment of your data offline onto your mobile device, do your work in a poor connected area, come back in and sync it, push it back up. And then quickly I get through where do we go from here. So first of all, where do we go from here? What's new in the network we're releasing? So in 3.7 and 12.1, which are coming out at some point in the near future, one of the things we've added is the ability to include the tracing flow direction on each edge element or edge feature in the JSON output. There are certain returns that you can get in tracing where you can say, give me a JSON file that is the graph, that is the result of this trace. Now the edge elements you can choose to include, does that edge go with the direction of digitization, against the direction of digitization, or is it indeterminate? Indeterminate and bidirectional are typically treated the same because we don't have a great word for either one of those. We also included propagator resetters. It's a very sort of, I don't know, esoteric is the right word, but a very complex topic that some partners have asked for. It essentially gives you the ability, as you traverse through a network using propagation, to say at this device, it resets it to some known value. We're also bringing along the telecom domain networks, so that's the sort of the big thing of this release as we go. And then other things we can do going from here is there's some further resource enhancements, utility network documentation, web and development, and web and mobile development documentation as we go. I always like to wait till I see phones go down as you take photos. A quick Google search will give you that one as well. And then there is a book that's out in the bookstore. That word was apparently really complex, bookstore. Out there of the top 20 essential skills written by Melissa and two of our colleagues, Remy and Chris Kremens. And so it's a great book. Pick it up. If that QR code, I think, will take you to the Amazon store where you can buy it. Not my personal Etsy where I'm selling bootleg copies.
It may take them to Esri Press, which they can then
Maybe.
piggyback to Amazon or wherever.
And then, as I say, thank you very much for coming. Please share your feedback in the app. I'm going to, there's how you can connect with us and all the different socials. And I'm going to let you ask questions now, but I'm going to back up and leave it on this page so you can grab that QR code if you choose to. While I say, is there any questions? Yes?
Is editing attributes considered, or can you have attributes that you can edit that won't dirty the area, or is all editing making an area dirty? Because I know there's a elevated permission for editing a utility network asset.
So the question was, is all editing of utility network features, I'll add some commentary to it, will all editing of any attribute in a utility network cause dirty areas? No. The other follow-up question to that, though, was, is the editing is controlled on utility network feature classes by the advanced editing user type extension if you are a creator from the portal. And so you cannot edit any attribution in a utility network unless you have creator plus the advanced editing utility user type extension. It used to be called the utility extension, which is why I keep mumbling the words. Or a professional or professional plus. Professional plus equate to standard or advanced in pro. So that will be blocked if you do not have those licenses and you try to edit anything in the UN. Yes?
All right. I have one more kind of a specific question. I was just trying to give other people a chance. So is it possible to run the enable topology tool without disabling topology first? The reason I'm asking is because one of the issues that I've been having with my own water sewer reclaim network that I've deployed is that as we're editing and validating topology, typically we'll still get we'll get clean areas as we're drafting, fulfilling the rules and everything. However, the purple dirty areas will occasionally stay behind, whether it's on the individual editing version and branch versioning or on default. And the only way to really get them to visually disappear is by completely disabling topology and re-enabling topology to force kind of like a refresh on it. Otherwise, if there's a little purple square of the dirty areas, even though the rules are fully consistent with each other, when you hit validate, it'll just say no dirty areas have been detected.
Okay, so that is a very specific question. The question was, when I'm editing in my utility network, sometimes I'm validating things, but the dirty areas, the purple ones, are remaining behind visually, even though if I attempt to revalidate, I get an error message that says, there's no dirty areas found here. And the theoretic solution to it is, can I enable my network topology over and over again without disabling first? So I'll start there. So no, in order to enable the network topology, you must disable it first. If you are running a full extent validate or a validate of a large enough extent, it should process all those dirty areas. Why your particular one isn't going away, I don't know, and I would say let's talk about it afterwards because I'm very curious as to why that's going on. in my mind, that's just a bug somewhere, probably a display bug somewhere that's not refreshing properly, or a versioning that's not refreshing, so we'd have to dig through it a little bit. But the simple answer to the question is, in order to enable a network topology, you must first have disabled it, or it must be brand new and having been created, never being enabled. And yes, validating, especially if it doesn't give you any errors, should make the dirty areas go away. Interesting question. Any other questions? No? Okay, I had an extra 3 minutes of demo time I could have done. All right, thank you all very much. So please, fill out the feedback. Let me know if you have any other questions. Come on up.